Have you ever wondered what the universe is truly made of? What if everything you see around you, every star, planet, and even you, wasn't made of particles but tiny, vibrating strings? Sounds impossible, right? But string theory proposes just that. The idea that the fundamental building blocks of everything are one-dimensional strings, vibrating in ways we can barely imagine. What if this theory could explain everything, from gravity to the forces that govern atoms? In today's video, we'll dive deep into string theory and explore its mind-bending concepts. So, are you ready to unravel the mysteries of the universe? What is string theory? Imagine for a moment that the entire universe, everything you see around you, is not made of solid particles, but rather something far more mysterious. What if, at the most fundamental level, everything, from the tiniest atom to the vastest galaxy, is made up of tiny vibrating strings? That's the essence of string theory, a revolutionary idea that suggests the basic building blocks of the universe aren't particles like we've always thought, but these minuscule one-dimensional strings. Now let's break this down. Picture a guitar string vibrating. Depending on how it vibrates, it produces different notes, right? Well, according to string theory, the vibrations of these strings determine the properties of particles like quarks and electrons, particles that make up everything in the universe. These strings are unimaginably tiny, so much so that they're smaller than even atoms. And just like different vibrations on a guitar string produce different sounds, the different vibrations of these strings give rise to all the different particles and forces that govern the universe. It's a bold claim, isn't it? It challenges everything we've been taught about what makes up the fabric of reality. But what's fascinating about string theory is that it brings a fresh perspective. If we could understand how these strings vibrate, it could be the key to understanding everything. The forces that bind atoms together, the way particles interact, even the force of gravity itself, all of it could be explained by the behavior of these tiny vibrating strings. So let's journey deeper into this world of strings and see how they could change our understanding of the universe. The four fundamental forces. We all experience the world through the lens of four fundamental forces. Gravity pulls everything downward. Think of the apple falling from the tree. Electromagnetism is what makes your phone light up, or a magnet stick to your fridge. The strong nuclear force holds the nucleus of atoms together, and the weak nuclear force governs radioactive decay. But here's the thing. Even though these forces shape everything in our universe, they don't fit neatly into the same framework. Each of these forces operates on different scales, with different rules. Gravity works on large scales, holding planets and stars in place, while electromagnetism governs the behavior of charged particles like electrons. The nuclear forces, on the other hand, are confined to the tiny space within atoms. But what if they could all be part of the same system? String theory suggests exactly that. These forces may have once been unified, existing together as a single force right after the Big Bang. It's a mind-blowing thought that these forces, so different in how they act, might have all come from the same source. String theory proposes that at very high energies, like those just after the birth of the universe, these forces were united in a single, elegant force. As the universe cooled, they separated, and over billions of years evolved into the four distinct forces we observe today. But here's where it gets exciting. String theory doesn't just unify these forces, it could potentially explain why they operate the way they do. If we could understand how they evolved from 1 to 4, we could unlock answers to some of the most profound mysteries in physics. Could string theory be the key to this unification? That's the question scientists are trying to answer today. Unification of forces. Imagine this. All the forces of nature, the ones that govern everything from the tiniest particle to the largest galaxy, could at one point have been unified, existing as a single force. It sounds like science fiction, but it's a real possibility according to string theory. The idea of force unification suggests that, in the early moments of the universe, right after the Big Bang, gravity, electromagnetism, and the nuclear forces, strong and weak, were not separate entities as we know them today. Instead, they were part of a singular force that existed in harmony, working together as one. Now, picture this force like a tightly wound spring. As the universe began to cool and expand, this single force began to stretch out, cooling down and splitting into different forces over time. So gravity, which governs massive objects like planets and stars, separated from the electromagnetic force that powers electricity and magnets. Similarly, the strong nuclear force responsible for holding atomic nuclei together, and the weak nuclear force responsible for radioactive decay, broke off from each other as well. What string theory proposes is that if we can uncover how these forces were unified, we might understand not only the origins of the universe but also a deeper connection between everything that exists. All of the laws that govern the universe could have come from this one unified force. The theory also suggests that, under extreme conditions like those found inside black holes or in the first moments of the universe, these forces might merge again. If we could access that information, we could potentially create a theory of everything, unifying all the forces of nature into a single framework. Could string theory hold the key to this ultimate unification? That's the journey scientists are currently on. Extra dimensions. String theory isn't just about small strings vibrating in a big universe. It takes us beyond the familiar dimensions of space and time. You see, we are accustomed to thinking in terms of 3 dimensions of space: up, down, left, right, and forward, backward, and 1 dimension of time. But in the world of string theory, that's just the beginning. To make sense of how the theory works, we need to accept the existence of extra dimensions, dimensions beyond the ones we can see, feel, or even imagine. Now don't panic. These extra dimensions aren't something you can just walk into. In fact, string theory proposes that these extra dimensions are compactified. They're tiny and folded up in a way that makes them undetectable with our current technology. In essence, these dimensions are hidden from our everyday experience, existing at scales so small that they're invisible to even the most powerful microscopes. But why extra dimensions? Well, it turns out that these dimensions are critical for string theory to be mathematically consistent. Without them, the strings wouldn't be able to vibrate in a way that explains all the particles and forces in the universe. Some versions of string theory even propose that there could be as many as 7 extra dimensions beyond the ones we know. These dimensions might be compactified in shapes called Calabi-Yau manifolds, fancy terms for the intricate geometric shapes that these dimensions could take. But while we can't see or directly interact with these extra dimensions, they could play a huge role in how the universe operates at its most fundamental level. If we could somehow uncover more about these hidden dimensions, it might unlock some of the deepest mysteries of physics, leading us to a fuller understanding of everything that exists. Supersymmetry. Imagine a world where every particle you know, every quark, electron, and photon, has a mysterious twin, a superpartner. This is where supersymmetry steps in. It's a concept within string theory that suggests that for every particle, there's a corresponding particle with different spin properties, often referred to as its superpartner. At first, it sounds a bit like science fiction, like something out of a superhero movie. But supersymmetry isn't just an intriguing idea, it's a crucial piece of the puzzle in string theory. You see, the fundamental particles we know today don't quite fit into the elegant equations that describe string theory. Enter supersymmetry, which smooths out some of these inconsistencies and helps bring string theory's predictions into alignment with reality. Now let's dive a bit deeper. Every particle in the universe has a property called spin, a fundamental characteristic that affects how the particle behaves in relation to other particles and forces. Particles like electrons, which are fermions, have half-integer spins, while force carriers like photons, the particles of light, are bosons with integer spins. According to supersymmetry, each fermion has a boson counterpart, and each boson has a fermion counterpart. This pairing helps to balance out equations and resolve some of the mathematical problems in string theory. While we haven't observed these superpartners yet because they're expected to exist only at very high energy scales, far beyond current technological capabilities, the idea of supersymmetry provides an elegant way to potentially explain some of the gaps in our understanding of the universe. If supersymmetry holds up under experimentation, it could open new doors in understanding particle physics and even the elusive concept of dark matter, the invisible substance that makes up a huge part of the universe's mass. Supersymmetry could very well be the key to unlocking mysteries we've been chasing for decades. Challenges and criticisms. As mesmerizing and elegant as string theory sounds, it's far from perfect. In fact, it faces a number of challenges and criticisms that have made many scientists hesitant to fully embrace it. And the biggest issue? The lack of experimental evidence. For any scientific theory to be accepted, it needs to be testable, something that can be observed, measured, and verified. However, string theory operates on such a small scale, far beyond what we can currently observe. The energy levels required to test the predictions of string theory are so high that even the most advanced particle accelerators, like the Large Hadron Collider, cannot reach them. This means that right now, we don't have a way to directly test whether string theory's predictions hold up in the real world. But that's not the only hurdle. Another criticism of string theory is the vast number of possible solutions it proposes. Depending on how you interpret the theory, string theory could describe an almost infinite number of possible universes, each with its own unique set of physical laws. Some critics argue that this makes string theory more of a mathematical framework than a truly predictive theory. Essentially, it's so flexible that it can explain anything. This makes it difficult to pin down a definitive prediction that could be tested. And then, there's the complexity. String theory involves highly advanced mathematics. Sometimes it feels like we're using abstract equations to describe things that we can't see or touch. For many, it feels more like an intellectual exercise than a practical theory that could be tested. Some even argue that scientists are chasing something that may never be testable, leading them away from more immediately fruitful areas of research. Despite these challenges, string theory continues to inspire physicists. The elegance and potential of unifying all forces into a single framework still resonate with many. And though we may not have all the answers now, the journey to understand the universe on its most fundamental level could take us to new frontiers of physics. Whether or not string theory becomes the ultimate theory of everything remains to be seen, but the pursuit of it is, without a doubt, an exciting chapter in the story of science. And that's a wrap on today's dive into the fascinating world of string theory. While it might seem like something straight out of science fiction, it's a theory that could change everything we know about the universe. What do you think? Could strings be the key to understanding the forces of nature? Let us know your thoughts in the comments below. If you enjoyed this journey into the unknown, don't forget to like, share, and subscribe for more amazing space facts. Until next time, keep looking up because the universe has so much more to reveal. Hey, have you ever wondered what happens when gravity gets so strong that it can bend the very fabric of space and time? Imagine a point in the universe where time itself slows down, light gets trapped, and even the most basic laws of physics seem to break down. Sounds like something straight out of a science fiction movie, right? Well, it's real. Today we're diving into the mind-bending world of black holes. How do they warp reality? What happens inside them? Stick around, and let's explore the cosmic mysteries together. The birth of a black hole. Imagine a star, massive and burning bright, living out its final days. For millions, even billions of years, this star has been fusing hydrogen into helium at its core, producing the immense heat and light that defines a star's existence. But one day, this process stops. The star runs out of fuel, and the delicate balance that has kept the star from collapsing under its own weight is broken. With no outward force to counterbalance the inward pull of gravity, the star begins to collapse in on itself. As the star's core contracts, it heats up and compresses, reaching temperatures and densities that seem unimaginable. Eventually, the core collapses into a point of infinite density, a singularity, where gravity becomes so strong that not even light can escape. Around this singularity forms the event horizon, the point of no return. Beyond this boundary, nothing, not even light, the fastest thing in the universe, can escape the gravitational pull of the black hole. This catastrophic collapse results in the formation of a black hole, a cosmic object so dense that it distorts space-time itself. Anything caught within the event horizon is trapped, pulled inexorably toward the singularity. From the birth of a black hole, the laws of physics as we know them seem to break down, creating a region of space where time, space, and reality as we understand it cease to behave in any predictable way. The formation of a black hole is not just the death of a star, it's the birth of an entirely new kind of object, where the ordinary rules of the universe are defied. Einstein's theory of general relativity. Before we even knew about black holes, there was a breakthrough in understanding the very nature of gravity itself. In 1915, Albert Einstein introduced his theory of general relativity, a radical new way of looking at the universe. Unlike Isaac Newton, who described gravity as a force acting at a distance, Einstein's theory painted a completely different picture. He proposed that gravity isn't a force at all but a curvature of space and time itself, caused by the presence of mass and energy. Picture this. Space-time, the very fabric of the universe, is like a stretched-out rubber sheet. When you place a massive object, like a planet or star, onto that sheet, it causes the sheet to curve and bend around the object. The more massive the object, the greater the curve. This curvature is what we perceive as gravity. What's more, this warping of space-time affects not just the motion of objects, but also the passage of time itself. Einstein's theory predicted that extremely massive objects like black holes could warp space-time to such an extent that they would create singularities, points where space and time collapse under such intense gravity that the laws of physics break down. At the heart of every black hole is this singularity, where gravity is so strong that not even light can escape. The discovery of black holes confirmed Einstein's theory, showing just how dramatically massive objects could distort the space-time fabric. Einstein's mind-bending ideas continue to shape our understanding of the universe, with black holes serving as the ultimate test of his theory's validity. Gravitational time dilation. Imagine you're near the edge of a black hole, looking out into the vastness of space. From your perspective, everything feels almost normal, except for one incredible phenomenon: time itself. You see, the closer you get to a black hole, the more time begins to slow down relative to the rest of the universe. Sounds like science fiction, right? Well, it's one of the most mind-blowing predictions of Einstein's theory of general relativity, and it's called gravitational time dilation. To understand this, picture time as a river flowing at a steady pace. When you're far away from a massive object, the river flows smoothly, and everything seems to happen at the normal rate. But as you approach a black hole, the river starts to slow down, and time itself stretches out. For someone standing far away from the black hole, it would appear as though your movements are happening in slow motion. On the flip side, from your perspective, everything outside the black hole would seem to speed up. It's as if time near a black hole is warped so much that it literally bends and distorts. If you were floating near the event horizon, the point of no return, you could look at a clock and see seconds ticking by normally for you, but to an observer far away, those seconds would stretch out like an eternity. In fact, if you were to dive into the black hole, you'd experience time at an entirely different rate, but to anyone watching from a safe distance, you'd appear to freeze in place as you approach the event horizon. Time, as we know it, bends and stretches in the powerful gravity well of a black hole, making it one of the most surreal experiences in the cosmos. Gravitational lensing, nature's magnifying glass. Let's take a moment to imagine you're stargazing, searching for distant galaxies and the hidden wonders of the universe. But there's one problem: some of these objects are so far away that no telescope, no matter how powerful, can see them clearly. That's where black holes come in, and it's a phenomenon so spectacular it feels like the universe itself is showing you a hidden trick: gravitational lensing. When light from a distant object like a star or a galaxy passes near a black hole, the intense gravitational field of the black hole warps space-time so dramatically that it bends the light, much like a lens bends the light passing through it. This bending effect acts as a magnifying glass, allowing astronomers to observe objects that would otherwise be hidden behind the black hole's event horizon. In essence, black holes become cosmic magnifying glasses, stretching and warping light from galaxies millions or even billions of light years away. Through this gravitational lensing, we can witness distant galaxies and stars in ways we never thought possible. It's as if black holes are creating shortcuts through the vastness of space, revealing hidden secrets of the universe. Astronomers use this phenomenon to peer deep into the cosmos, often uncovering galaxies that would otherwise be invisible. It's one of nature's most fascinating tricks, showing us how black holes can not only bend time but also warp light, revealing a universe far more complex and intricate than we ever imagined. Spinning black holes and frame dragging. Now let's take a look at something even more mind-bending: the spinning black hole. Imagine a black hole that's not just sitting there like a cosmic vacuum, but instead it's spinning faster than anything we can imagine. The spin of a black hole is so intense that it begins to drag the very fabric of space-time around with it. This phenomenon is known as frame dragging, and it's a key feature of rotating black holes, also called Kerr black holes. When a black hole spins, it doesn't just warp space-time like a non-rotating black hole, it twists it. Picture a marble placed on a rubber sheet. If the sheet is stretched flat, the marble will create a small depression, causing objects nearby to roll toward it. Now imagine if the sheet itself were spinning. the marble would start to spiral around the depression as the fabric of the sheet twists beneath it. That's similar to how space-time behaves near a rotating black hole. As the black hole spins, it drags everything around it into its rotation, creating an effect so powerful that it can even affect the orbits of nearby objects and light paths. The closer you get to the black hole, the more extreme this twisting of space-time becomes. This effect is so strong that if you were caught near a spinning black hole, your spaceship, or any object, would be pulled into a spiraling motion, trapped in the swirling currents of space-time. This frame-dragging effect can even cause light to follow a curved path, making the black hole appear distorted or stretched. So, not only does a black hole bend space and time, but its very rotation can drag everything, even light, into its gravitational whirlpool. The event horizon. Let's now talk about one of the most fascinating and terrifying features of black holes. The event horizon. This is the boundary that marks the point of no return. Once you cross this threshold, there's no coming back, not even light can escape. The event horizon isn't a physical surface you can touch. Instead, it's a point in space where the escape velocity exceeds the speed of light, meaning that nothing, no matter how fast or powerful, can break free from the black hole's pull. As you approach the event horizon, things start to get seriously strange. For one, time itself behaves differently. To an outside observer, you would appear to slow down and freeze as you get closer to the event horizon. Your image would stretch and distort as you approach the point of no return, like a stretched-out rubber band. Meanwhile, from your own perspective, everything might seem perfectly normal. You could even continue falling toward the black hole. But from the outside world, it would look like you're trapped in suspended animation. What happens to you once you cross the event horizon? Well, nobody really knows. We can't observe the inside of a black hole because light can't escape, and anything that crosses the event horizon disappears from view. The theories range from the possibility of being stretched into a long, thin strand, a process called spaghettification, to the idea that your journey could be completely beyond our understanding of physics. But what we do know is that once you cross that line, the rules of space and time no longer apply in any way we can comprehend. Black holes and the fabric of space-time. Black holes don't just challenge our understanding of gravity or light, they force us to rethink everything we know about the very fabric of space and time itself. In fact, black holes are so extreme that they create regions where space-time is warped to the point where our current laws of physics break down. When we talk about the fabric of space-time, we mean the four-dimensional continuum in which all objects exist. It's like the stage on which the drama of the universe plays out, but when a black hole forms, it distorts this stage so drastically that the usual rules don't apply. At the heart of every black hole lies a singularity where space-time curvature becomes infinite. Imagine a point in the universe where both the laws of space and time no longer function in any way we understand. At this point, all the forces that govern the universe, including gravity, electromagnetism, and the nuclear forces, collapse into one. The singularity is where all our current theories fall short, and it's a place where physics as we know it simply can't describe what happens. And yet, black holes are not just curiosities, they're natural laboratories where space-time itself is tested to the limits. As scientists continue to probe the nature of black holes, they are searching for a theory that can combine general relativity, which explains gravity, and quantum mechanics, which explains the behavior of subatomic particles. Finding this theory of everything is one of the biggest challenges in modern physics, and black holes might hold the key to unlocking this mystery. The deeper we explore, the more we realize that black holes are not just destructive forces, they are fundamental to understanding the very nature of reality. Well, there you have it. The incredible mysteries of black holes and how they bend the very fabric of space and time. It's amazing to think how much we still have to learn about the universe, right? What are your thoughts on black holes? Do you think we'll ever fully understand them? Drop your thoughts in the comments below. I'd love to hear what you think. If you enjoyed this deep dive into space, don't forget to like, share, and subscribe to Space Facts for more mind-blowing content. Until next time, keep exploring the cosmos. Have you ever wondered what the future of lunar exploration holds? Imagine astronauts walking on the moon once again, but this time, it's not just a visit, it's the beginning of humanity's long-term presence on our closest neighbor. What if the moon could become a launch pad for missions to Mars? In 2025, we're about to witness some of the most exciting lunar missions ever. From international collaborations to groundbreaking technology, the moon is set to become the center of space exploration. Are you ready to explore what's coming next? Let's dive in. NASA's Artemis program. The excitement surrounding NASA's Artemis program is palpable as we edge closer to a new chapter in lunar exploration. The Artemis mission is not just a return to the moon, it's a stepping stone for humanity's journey to Mars and beyond. The Artemis II mission, scheduled for 2026, will be the first crewed flight around the moon since Apollo 17, marking an incredible milestone. 4 astronauts will embark on this historic journey, orbiting the moon before returning to Earth. Imagine the thrill of seeing our Earth from space once again, just like Apollo astronauts did decades ago. But what makes Artemis III, set for 2027, even more exciting is its ambition to land astronauts near the lunar South Pole. This is no ordinary landing site. The South Pole is a treasure trove, believed to contain vast amounts of water ice. This ice could potentially fuel future missions and even support a sustainable lunar presence. For the first time in history, we'll be walking on an uncharted part of the moon. NASA's ambitious plans go beyond just visiting. They're focused on building a sustainable lunar presence with habitats, scientific outposts, and resource mining, all key for preparing us to explore the Red Planet. The Artemis program is set to revolutionize not just lunar exploration, but the entire future of space travel. With technology, innovation, and international collaboration on its side, Artemis is paving the way for a new era of space exploration. Get ready to be part of history in the making. China's Chang'e missions. China's Chang'e missions are pushing the boundaries of lunar exploration, and 2025 promises even greater strides. The Chang'e 6 mission, launching in 2025, will make history by returning lunar samples from the moon's far side, an area that has never been explored by humans. This mission will touch down in the moon's South Pole Aitken Basin, one of the largest and most ancient impact craters in the solar system. Scientists believe this region holds answers to the moon's earliest history and secrets about the formation of the solar system. The Chang'e 6 mission represents more than just a scientific venture, it's a step toward China's ambition to lead in space exploration and lunar development. But that's just the beginning. By bringing back lunar samples from an untouched region, China will help scientists around the world unlock secrets about the moon's composition and the presence of water ice, which could be used for fuel and other resources in future missions. China's growing space presence will enhance international collaboration, especially as it partners with other nations to share data and findings. The Chang'e program is not only about exploration, it's also about sustainability, as China looks to build on its achievements and create a permanent presence on the lunar surface. Chang'e 6 is poised to deepen our understanding of the moon and reshape the future of lunar exploration for generations to come. India's Chandrayaan missions. India's space agency ISRO has been making remarkable strides in lunar exploration, and the next chapter of this journey is incredibly exciting. Following the success of Chandrayaan-2, which placed a rover near the moon's south pole, India is setting its sights even higher with Chandrayaan-4, set to launch by 2027. The success of Chandrayaan-3 in 2023, which landed near the South Pole, made India only the 4th country in history to achieve a soft landing on the moon. This achievement has not only positioned India as a rising space power, but has also opened up incredible scientific opportunities. Chandrayaan-4 will be even more ambitious, with plans to return lunar samples to Earth. These samples will help us understand the moon's geological history and its potential to support future lunar missions. But there's more. ISRO's focus on the moon's south pole is crucial because this region contains water ice, one of the most valuable resources for sustainable space exploration. India's lunar missions are poised to contribute vital data on the moon's resources and how they can be used for future space exploration. As part of an international lunar science community, India is playing a pivotal role in unlocking the moon's secrets. The Chandrayaan missions are paving the way for India to not only contribute to lunar science, but to become an essential player in the exploration of our solar system. India's lunar ambitions are just beginning, and the next mission is sure to push the boundaries of what we know about Earth's closest neighbor. Commercial lunar landers. The future of lunar exploration isn't just about governments, it's also about private companies stepping up to the challenge. In 2025, we're going to see more private sector involvement than ever before, with commercial lunar landers like Intuitive Machines and Astrobotic leading the charge. These companies are not just launching payloads into space, they are taking humanity a step closer to creating a permanent lunar presence. Intuitive Machines' IM-2 mission, set to launch early in 2025, will land near the Shackleton crater, a region that holds clues about the moon's water ice deposits. This mission will open doors to the exploration of lunar resources that could one day be used for fuel, water, and life support on the moon. Astrobotic's Griffin 1 mission, scheduled for late 2025, is another milestone in private lunar exploration. This mission will deliver scientific payloads to the moon, including experiments and technologies that could be vital for establishing a sustainable lunar infrastructure. The rise of commercial companies in lunar exploration signals a new era, one where private enterprise plays a major role in space exploration. These companies are helping to drive innovation, reduce costs, and make space more accessible. In fact, many experts predict that commercial lunar landers will not only change how we explore the moon, but will also play a critical role in future Mars missions. The partnerships between private companies and space agencies are forging a path toward a future where lunar exploration isn't just for a select few but is a global effort. The possibilities are limitless, and the moon is just the beginning. International collaborations. As the race to the moon accelerates, international collaborations are becoming a crucial part of the lunar exploration landscape. These partnerships are not just about sharing the costs of missions, but about combining the expertise, technology, and resources of multiple nations to achieve something greater than any one country could accomplish on its own. In 2025, we will witness some of the most exciting joint lunar missions, with countries like India, Japan, and even the United States teaming up for groundbreaking research and exploration. One such collaboration is the Joint Lunar Polar Exploration Mission, which India and Japan are developing. This mission will focus on the lunar South Pole, an area that holds vast reserves of water ice, one of the most valuable resources for sustaining human presence on the moon. By joining forces, these nations will combine their scientific and technological capabilities, ensuring that the mission is as successful as possible. The data collected will be vital for understanding the moon's resources and creating a sustainable future for lunar exploration. These international partnerships are more than just about scientific discovery. They're about building a united front for the future of space exploration. As nations collaborate on the moon, they are also laying the groundwork for future cooperation on Mars, asteroids, and beyond. The exchange of knowledge, technology, and expertise ensures that all countries involved benefit, while the collective achievement of humanity is pushed further into the cosmos. The moon has always been a symbol of human curiosity and ambition, but now it's also a symbol of collaboration. And as we work together to uncover its secrets, we also work toward building a future where space exploration is a global endeavor. Future lunar infrastructure. The vision for the moon is rapidly transforming from short-term missions to long-term infrastructure. The Lunar Gateway, a project initiated by NASA, is set to play a pivotal role in this transformation. This space station, positioned in lunar orbit, will serve as a staging point for crewed missions to the moon and beyond. The Gateway will provide astronauts with a safe and reliable location to dock, refuel, and resupply before heading to the moon's surface. This infrastructure is crucial for creating a sustainable human presence on the moon, and will be key in our efforts to explore Mars and other parts of the solar system. But the Gateway is only one part of the bigger picture. To support long-term lunar exploration, there's a need for advanced technology that can harness the moon's resources. NASA, along with other space agencies, is developing systems to extract water from the moon's ice deposits and use it for fuel, oxygen, and even drinking water. This technology is vital for sustaining astronauts on extended missions. Additionally, research into building habitats using lunar soil is underway, as this will allow for the creation of permanent lunar bases that can support future generations of astronauts. These efforts are laying the foundation for a self-sustaining lunar outpost that doesn't rely on Earth's resources. The goal is not just to visit the moon, but to build a lasting presence that can support human life and serve as a launchpad for further space exploration. With the right technology, international collaboration, and a focus on sustainability, the moon will become humanity's stepping stone to the stars. As we lay the groundwork for this future, We're not just expanding our reach into space, we're securing humanity's place as a multi-planetary species. So there you have it. 2025 is shaping up to be an incredible year for lunar exploration. With groundbreaking missions, international partnerships, and cutting-edge technology, the moon is closer than ever to becoming humanity's next frontier. What do you think the future holds for lunar missions? Let us know in the comments. Don't forget to like, share, and subscribe to Space Facts for more exciting updates on space exploration. The cosmos is full of wonders, and we're here to uncover them together. Until next time, keep looking up.